Today we will be talking about a new topic in our class of minerals, crystals and minerals, and this topic is classification of minerals. We were talking last time about the physical properties of minerals, and today we will use their chemical composition to create this classification of minerals. So the outline of this lecture and actually the next two lectures, uh, we will be talking about the classification of minerals for two lectures or three. Uh, we will talk about crystal abundance of elements, chemical classification of minerals, and then we will have an idea about native elements, sulfides, halogenides, oxides and hydroxides, carbonates and nitrates, borates, sulfates, and silicates, and other organic compounds. For the crystal abundance of elements and how they are distributed by amount, we know that Earth's resources include thousands of minerals, around like from 3,700 to 4,000 minerals. These minerals have a very good economic or commercial in our industrial life, and the Earth contains 8 abundant chemical elements. The important 8 chemical elements are oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium. Then the other elements. You see the percentage of the oxygen is the major one, 47% is oxygen. Silicon comes next, 27%. And you will see the silicon and oxygen are the two most abundant elements present in the Earth's crust. And other elements, they just constitute the rest of the percentage, such as aluminum, iron, calcium, sodium, potassium, magnesium, hydrogen, phosphorus, barium, and strontium. And still, metals like copper, lead, zinc, which really are important elements, they only present in a very small proportions. So then we move to the most abundant minerals, not elements, minerals in Earth's crust are silicates, such as feldspar, mica, quartz, pyroxene, olivine. And also you still have non-silicates, which they represent less than 10%. And the most common of non-silicates are carbonates, oxides, halides, sulfides, and others. Okay, so every mineral can be identified by several of its physical properties that already we have studied the physical properties of the minerals before, and the crystal chemistry here. As I said before, around 4,000 minerals are occurring on Earth. Out of this number, only 24 minerals are common. They represent up to 90% of the mineral constituents in the Earth. Okay, minerals may be composed of one single element or more. One single element, such as gold, or combination of elements, which are the rest of minerals. Minerals which are composed of more than one element are bound together by chemical bonding. The main classes for our classification to study are elements, oxides, halides, sulfides, carbonates, phosphates, and silicates. Of course, there are many subclasses, but still we cannot study all that because we will not have enough time for it. The chemical classification of minerals, we divide those in the following classes. There are 10 classes. As you can see here, native elements, native metals, alloys, sulfides, halogenides, and and oxides and hydroxides, antimonies, carbonates, nitrates, borate, sulfate, phosphates, and silicates, of course, and organic compounds. Let's talk about native metals and alloys. Native metals include aluminum, cadmium, chromium, copper, gold, indium, and 20 elements occur in nature in a pure or nearly pure form. That's why we call them as the native elements. There are three families: metals, semi-metals, and non-metals. Native metals make up three groups: gold group, gold, silver, copper, and lead; platinum group, composed of platinum, radium, and osmium; iron group contains iron and nickel. Okay, now native non-metals and semi-metals include antimony, arsenic, bismuth, diamond, graphite, selenium, silicon, sulfur, and tellurium. This is just an idea about like native elements. Now let's talk about important class of our minerals called sulfide. They have a very good economy importance. So the sulfide class includes four categories also, as you can see here: sulfides, sulfur salts, sulforsinates, and sulfantimonides. Okay, sulfides are economically important, as I said. You will see examples of sulfides such as galena, which is a lead sulfide, which is very common sulfide mineral. And the picture of the photo of galena, you'll see it on the right side here. Yes, it crystallizes in the cubic system. And pyrite, same thing, but iron sulfide here, and this is a picture of it. Then you will have sphalerite, which is zinc sulfide, where we can find the zinc atom is surrounded by 4 sulfur atoms. And also in chalcopyrite you will see copper iron sulfide, where the copper and iron ions can be having regular substituted in zinc position of original sphalerite atomic arrangement in the previous one. And I will show you in a picture now of a mixture of all of them: galena, pyrite, sphalerite, and chalcopyrite. Here you go. Very nice, very beautiful picture of the collection of sulfides of galena, pyrite, sphalerite, and chalcopyrite. Okay, so this is the first important class of our minerals. Inshallah, in our next lecture, we will learn about another class of minerals called halogenides and oxyhalides. Thank you and have a nice day. Bye.